Bismillahirrahmanirrahim. Today our topic is what are atomic orbitals. Actually, atomic orbitals are mathematical functions that describe the wave nature of electron in atom. It means the probability of finding an electron in a specific region around the nucleus of the atom. There are four different kinds of orbital denoted by S, P, D and F. They are different shape. They have different shape, and now in our syllabus we consider S, P and D orbital shapes. An S orbital, it's look like a spherical shape with a nucleus at its center, and a P orbital is a dumbbell shape, and it's also called a loop, and its nucleus at its center. And four d orbitals are clover leaves like, and one orbital is shaped like an elongated dumbbell with a donut around its middle. The orbital in atom are organized into different layer of electron shells or shell energy levels. Orbital wave function is denoted by sign and is means to represent the probability of finding an electron, or its means is used for the representing the coordinates of an electron. According to the quantum atomic model, an atom can have many possible number of orbitals S, P, D and F. These orbitals can be categorized on the basis of their size, shape and orientation. A smaller size orbital means there is a greater chance of getting an electron near the nucleus, like hydrogen molecule or hydrogen atom. It's a hydrogen atom. In this hydrogen atom, the number of electron is 1, which is near to the nucleus, so the chance of electron is present near to the electron. Now we describe the shape of S orbital. Shape of S orbital is spherical, and its nucleus is center of the sphere, and all axes are crossed into the sphere like a symmetrical. It means the S orbital are spherically symmetric, having the probability of finding the electron at given distance equal in all directions. Because it is spherical, electron may be present here, any place of there. The size of the S orbital is also size, and energy of S orbitals also increase the number of shells. Number 1, 2, 3, 4, 5, 6, 7. The number of shells is also called principal quantum number. The size is increased, the number of shells is also increased. Now we explain the shape of p orbitals. Each p orbital consists of two sections known as loops, and which lies on either side of the plane passing through the nucleus, like that. The 3p orbitals differ in way the loops are oriented, whereas they are identical in terms of size, shape, and energy. As the loop is lie on the axis x and y axis and z axis, then the orbitals are designated as 2px, 2py, and 2pz. Now we second that there are 3p orbitals whose axes are mutually perpendicular, and these are similar to s orbital. The size and energy of p orbital increases, and increase in the principal quantum number means number of shell is increases, the size and energy is also increased. Now we describe the shape of d orbitals. D orbitals are present in a transition metals which have a dual valencies, means some elements or atoms contain +1, some elements contain +1 and also +2 and +3. The d orbital shape, you know that is a clover leaf like, and four shapes are same as clover leaf like. One dx, second dy, dz, and dx square minus y square, and fourth one is dz square, is dumbbell shape, and around the dumbbell is a donut in the neck. These orbitals are designated in these form. Out of these 5 orbitals, first 4 orbitals are similar to each other and one is a different, but the energy all 5 orbital is the same. Now we explain here nodes. What are nodes? Nodes, the region or space around the nucleus where the probability of finding an electron is 0, are called nodes. How we know that how much node present in 1s orbital, 2s, 3s? It's too easy. Its formula is principal quantum number minus 1. Number of shells means minus 1. If we consider 1s means 1 is here. 1 minus 1 is equal to 0, means 0 nodes. So number of probability of electron maximum present in 1s orbitals, and 2s means 2 minus 1 is means 1 node is present. That white region is called a node, and as usual 3, 4, 5, 6, 7 means 4 means 3 nodes are present, 3 means 2 nodes are present, means the finding of electron is 0. And now we describe atomic orbitals or orbital wave functions. The orbital wave function can be represented by the product of two wave function. One is radial and other is angular. A wave function. A node is a point where a wave function passes through zero. Wave function means is a sample that and is a zero. It means the nodes classified into two types. I'll explain again. A node is a point. According to wave function, we can describe a node. What is node? A point where a wave function passes through a zero is node, called a node according to wave function, and it has a two types, radial node and angular node. Radial nodes described as the spherical surface around the nucleus where the probability of finding an electron zero. It means it belongs to spherical shape yani S orbital. Angular node, the plane or planar area around the nucleus where the electron probability is zero. It means p and d orbitals. Clear here? Here is some picture of p orbitals, 2px, 2py and 2pz according to the nodal plane. 2px nodal plane is vertical, 2py is also vertical, but 2pz may horizontal nodal plane are present. Px may left hand side and it's a right hand side. Now we consider d orbitals like that with nodal planes. In this we describe the which shape is belong to 3dz or 3dyz. Is both are similar but the direction are different. How we know that which one is 3dz xz or which one is 3dyz? If the nodal planes or axis x, y and z is like that, like clockwise present, then the dyz direction is right hand side and the xz direction is left hand side. Another differentiation is that if dyz shape is present, the loop of the orbit d orbital is present on the x-axis x. That loop is fully covered with the shape and other is below the axis, not present in y and z axis. When we consider dxz, then one loop in the y axis is present in above the axis and one loop is below the axis. Similar to that picture, in this picture the X and Y axis rotate anti-clockwise. XZ is also anti-clockwise. In this picture, if the axis is rotate anti-clockwise, the direction of DYZ is right hand side DYZ and XZ is left hand side. And you look at clearly, if it is Y, so no one present in a y-axis, simple that. But x-axis में, in x-axis the loop is fully covered the axis line, and the another loop, opposite loop, is below the axis line. And the second picture of the XZ, y-axis loop, y-axis line covered with one loop, and other opposite loop is below the y-axis line. And dx and dyz is totally different. X square and y square. Dxy is between the clover leaves are present, are between the loops and the flower like, and dx square y square is like a butterfly like. I think my lecture is clear to your concept. So Allah Hafiz.